doesn't really affect me unless it's very complicated, involved question that takes like 20 minutes to do.
If you give me a math problem that has 7 steps and you just got
This was the last part, right? In the last minute I explained this. We were about to make a graph of exponential logarithmic functions again. Let me review this. Logarithmic functions are inverses of exponential functions. So their graphs are just reflections of exponential functions graph along y equal x line. Where is y equal x line? Right between x and y. So when you flip this across this line, you get something like this black one. When you flip this one, you get that guy. So in short, when you have a large base, your graph rising slowly into eventually infinity. When you have a small base, but not too small, still bigger than 0, I don't mean negative, bigger than 0 but small, less than 1, it's declining to negative infinity but slowly. And every logarithmic function meets each other at 1, 0. They all visit this point, just like exponential functions, 0 point is visited. And you flip this, 0 and 1, it becomes 1, 0. You know, we flip in inverse. And they all visit this point, okay? You can get all this data. Look, everything written here, you can read it from this picture, description. Domain is 0 to infinity. Range is negative infinity to infinity. You know how to find range from graphs. Vertical asymptote, they never touch x equals 0 line or y-axis. They tend to get close but never touch. That's vertical asymptote. They pass through 1, 0, large base increasing, small base decreasing. Knowing this, we can now figure out the graph of logarithm base 2 of some mess and then some other number coming up. Okay, where do we start? There is some help. It says, if you want to figure out this graph quickly, you need to use graph of, this is 2 by the way, logarithm base 2x. Start with making graph of logarithm base 2x because this is not going to be too different. This -4 and -5 is going to make some kind of transformations. And you will tell me what type once we figure out the graph of this thing, okay? And then the rest is just smooth sailing. We'll find domain or range from the graph. We just need to look at the numbers. And equation of the asymptote as well. Okay. Why don't we plot logarithm base 2x first? As much as we could, as best as we could. Just tell me, please, which shape are you going to obtain? Declining or increasing? For logarithm base 2 of x. Increasing. Base 2 be more than 1, right? 2 is more than 1. So this is my graph. That's it. This is the graph of log base 2 right here. Alright, we perfectly know what this point is. What is this point? What is that? 1, 0. And this is again only log base 2 of x. Okay? Now, all you need to do is discover what kind of transformation this and that will make. Alright, let's start with the red one. What kind of transformation happens if you subtract a number directly from x, not from the entire function, from x? What kind of shift?
Right 4.
Right 4. From 2.6, section 2.6, right 4. This is going to move 4 units to the right. Alright, how about this one? What kind of shift is this? down 5. So, can we do this all once? Down 5, right 4. So 2, 3, 4. 2, 3, 4, 5. So the point first moves here. 4 right. Right? 1 becomes 5 if I move it 4 right. And 5 down. This point is gonna go 5 down. 1, 2, 3, 4, 5. There you go. It's a very poor picture, unfortunately, because I'm out of region. Okay, I want to show you one more thing. The original function had this line as an asymptote, right? It was tending close to this line. This is the original asymptote. X equals 0 is the name of the asymptote of the original log 2x. This is log 2 base 2 o x minus 4 and then a minus 5. I wonder what this gets closer to. New asymptote. Okay. It gets closer to something. Right? I want you to name it. What is the equation of this line? Anyone? 4. Do you agree? So this point is, where's this point? It's at 5 comma negative 5. Because we went 5 down here. And this point was 1 unit far from the left to the right of the asymptote. So this one should be still 1 unit to the right of the asymptote. If the distance is 5, this should be 4 then. So I know the new location of the new asymptote. It's equal to x equal 4. What else is needed? We've done this one. Domain is required. Again, to find out domain of any graph, you need to compress it to the x-axis. Smash this to the x-axis, upward. What kind of shape do we get? We get this shape, this part. But you need to write this as an interval. Going all the way to infinity, so that part is clear to me, I just don't know where it starts. 4. Oh, are we gonna include 4 though?
No.
Yes? No. Because we never touch this red line. This function can never attain the value at 4. Because if you substitute 4 minus 4 is 0. What is logarithm at 0? Any logarithm at 0 is undefined. You cannot take 4 into your domain. It's undefined. So this side has to be open, or parentheses. Okay, what else is asked? We found the asymptote. This is asymptote. X equal 4. We need range. For range, you need to push this to the y-axis now. Push this to the y-axis. And I believe we are going to color, look, these blue dots is gonna start falling and shading here. How far? I think this is the maximum they rise, right? This is more robust, so I need to read this number. Is that right? No. Although it looks like it's going all stable here, now this guy is rising more and more this size. And it's eventually going to cross this axis, x-axis. It will cross. I don't know where, but it's going to cross. And it will go all the way to the moon. this way is unlimited. And that way is unlimited as well, right? Look at the arrow. So what's the final result? Negative infinity, positive infinity. All right. That was. How many problems did we have with this? This was 17. It was a large set, but some questions are 10-second questions. All right. The right picture seems like not this. We're never crossing y-axis. You need to tend closer to x equal 4, right? This looks like a good candidate, but let me evaluate the others. Nope, not this, not that, not that. We're not crossing y-axis. So it looks like part A. All right, domain and range already been figured out, 4 to infinity. And the entire y-axis was the range. And the asymptote was at 4. Okay, we have one more question, actually no, 2 more. Okay, and then an application. Alright, same idea. Find the interval notation, find the domain interval notation. But this time, why don't we use our smarts? This time, let's not sketch this. I mean, I know you can sketch it, but why don't we use our brain this time? What do you want? Domain means, again, all the numbers you can insert here in place of x, multiply by 8 and 9, and we want that logarithm to be positive always, because logarithms, just like square roots, do not work with negative numbers. Again, any logarithm must have only positive axis going in if it's only x. So we want to keep this inside positive. That's our goal in any domain finding question. This is not just x, some bunch of other items inside, but the aim, our goal is the same. Keep positive. Try to enter a negative number to a logarithm, it's gonna fail, undefined. Try with a calculator. So, I just put this in sentence, words. How do you write this thing, this goal, in mathematical terms? You need to keep 8x plus 9 positive. So what is the right symbol to say keep positive this thing? Equal to 0? What? No, but there's a better. Chantal? Yeah, absolute value makes it positive. No. Maybe when I say to keep, this is a too strong one. Should be more than 0. Yeah. You like more than better, right? So when I say more than 0, this is the symbol we're looking for. So we are wondering what initial value of x makes this thing more than 0. So you need to just solve for this. Subtract 9, right? And now we get 8x on here. And this 9. What is it saying? Shall we change the direction because we subtract the negative number? No, it's only in division. So we're good. Divide by 8. Shall we change the sign? No, it's positive number you're dividing. Just checking. Here we go. What does this say? Inside of logarithm will be more than 0 as long as you keep picking numbers more than, greater than minus 9/8. So here is the region you guys should be picking numbers. Negative 9/8 is here, somewhere here. It's about minus 1.12 something. We must be picking more than this. Any number you pick from this region, you're good. Like 0 is good. Plug in 0, for example. 8 times 0 plus 9 is positive. Plug in 10, you're good. How about minus 1? Is minus 1 gonna work? Minus 1? Because minus 1 is somewhere here. It should work. Plug in minus 1, 8 minus 1 plus 9 is positive 1. It works. Okay? About minus 2. Minus 2 times 8, no, it's too big, negative. So this is the cutoff, and we should not include that value. Because if I include exactly minus 9/8 here, minus 9/8, it's gonna cancel out and become 0. Do we like zeros in logarithms? Can you compute logarithm of a 0? No. So we stay off that value, go further to the right. And how do you write this in interval notation? This is, do not change this into, please do not change it into decimal. Only keep things in rational numbers, okay? This was a short one. I mean, you didn't have to sketch it, that's what I mean. Do you have any questions? It's just basic reasoning question. Do we care what this number is? No, we'll never deal with the number. Small or big. Keep logarithms more than 0 so they are happy. Alright, one application of logarithms, actually you hear this on the news a lot. I mean, United States does not have many earthquakes unless you're on the west side. Right? This side is pretty safe, but I heard some Ohio had some earthquakes last week, right? Last year. Did you feel it? There was a small one. Anyways, they say, oh, the magnitude of this earthquake was 5.9. They say 7, 8, all these numbers are popping up. But how big is scale 8, size 8 earthquake or size 7? It's actually a big difference. Like, when I say size 6 and size 5, oh, it's just one scale up. But no, this size 6 earthquake is 10 times stronger shake than size 5. Imagine I shake you 10 times more. It's 10 times. Because of the logarithmic calculations, it seems like only one size, but no, it's actually the difference is 10. Well, who came up with this idea? The guy called Richter. It's called Richter scale. But basically what they do is, there is a reference shake amount. They just measure the current measurement of the earthquake, if it happens now, to that reference value, and they take ratio. And they take logarithm of that ratio. Whatever the number is, that's the scale amount. Like you get 5.9 out of this, that's your Richter scale. Alright, I know 5.9 is less than 6, but still like there is some power difference, okay? Alright, what is the question here? Somebody took a measurement, and for example, there are several stations in the United States and in the world. And they come up with these announcements. Somebody says 5.4, and the guy in Russia says no, the real correct measurement, because they have a better machines. They say it was 5.9 rather than 10 raised to the 5.4. They say my machine measured at 5.9, and some stations are more credible, and the news agencies go with those stations as well. So we're just figuring out, we just need to figure out in part 8, how big, I mean this is what the center announced, 10 raised to the 5.4 times the reference density of the earthquake. We just need to figure out what this number means in Richter scale, okay? So this is their announcement. You need to change it to scale. All you need to do is use this formula of Richter scale calculation. You need to put the measurement, original estimate here, and this is I0 is the reference shake amount. And what is that original estimate announced by somebody? It was 10 raised to the 5, right? This is the original and this is the revised one. So we take 10, 5 to the 4th times the reference scale, and we divide it by the reference scale. Of course, these will cancel, and you're left with this number. And here's the question. When you say, oh, it's logarithm of 10 raised to the 5.4 to the public, they won't understand nothing. What is log? They will say. So you need to give them a number so they can make sense. Oh, size 5 is big, size 6 is bigger. Okay, they will make sense. So you need to change this answer into a language dumb people can understand. General public can understand. So there comes your math skills. Now you will go and say your neighbors, oh, I know how to do this math. This number actually means, okay, who can compute this? Yeah, because a common logarithm, a logarithm without any base, actually has a secret base 10. And we learned yesterday, not yesterday, on Friday, that one of the logarithm rules says you can actually change that into exponential and compute, but the shortcut is if you have a logarithm with a base and a power of base of the power match, if this is a match, then you can kind of wipe these off, ignore them out, and only the answer is this, whatever top number is. So by that reasoning, you can cross this out and get, it's a size 5.4 earthquake, moderate one. Very severe but moderate earthquake, okay? So why did they come up with these Richter scales? So everybody can understand what language is this. When you say size 5 and 6, every child will understand. But technically the size is 10 to the raised to the 5.4 times the reference earthquake power, I0, whatever their reference is in that machine. Okay? I believe we are going to now revise our, we are going to compute our revised estimate for density, for magnitude of the revised estimate. So you're going to repeat this work for the new measurement announced, which is 10 raised to the power 5.9, I believe. So what are we going to do? We are going to repeat the same procedure for the revised estimate, which is 10, 5 to the 9th, I sub 0. So all you need to do is put this into logarithm. Yeah, they will cancel this too. And these will cancel as well, log base 10 and log 10, exponential base 10. And the answer is 5.9. Again, this is about 5 times stronger earthquake. 5.9 scale, 5.9 is about maybe 6 times. It's not a direct relation, you just don't subtract these numbers, but maybe 6 times more stronger. So it matters a lot. It looks like a small change in the digit. Imagine 6 times stronger shaking. Okay? But actually it says how many times more intense. That was my next question. We need to compute that. How many times more intense was the earthquake than originally thought? Round to first estimate. So you need to, for this, you need to take the raw data. This is the raw data. This is the revised number. This is the old number. They just want us the ratio of this so you can figure out how many times revised one is stronger than old. I said estimate 6, but let's compute it much precisely. Alright, how do you guys cancel, reduce a fraction which has the same basis with exponents, different exponents and same basis? Is there a way to reduce them? I'm asking this rule actually. If you have a to the n, same a but a different power, is there a way to combine these powers? A raised to what? You know that?
Can we just subtract them?
Yep, we subtract the bottom one from the top one, n minus m. So 10 to the, let me write this again, 5, 9, 10 to the 5 fourth. 5.4 is actually 5.9 minus 5.4, and that makes 10 raised to the, what, 0.5? Yeah, I wasn't correct when I say 6 times stronger. This is a lot less. You need to compute 10 raised to the 0.5 with a calculator. I can't do it manually. 10 raised to the power 0.5. 3.16 is about 3 times, I lied. 3.16 times stronger earthquake. And this is about, but it says round to the 1 decimal, 16 rounds to 2, 3.2. Okay? Any questions? Alright, let's finish this off and we can go into further logarithm properties. Okay? I got 32%. Alright, we are starting 10.4, I'm sorry, 4.4 next. If you don't have any questions? We will mostly revisit what we learned in logarithms and put 3 more rules. So the first 4 on the left is already from 4.3. You recall these, right? Section 4.3, just done with this. Again, let me review it. Whenever you see 1 in a logarithm, no matter what base is, 1 makes your logarithm 0. 1 is a 0 maker, okay? Second, if you have a matching basis and a number, base and number match, it's 1. Base and number match, but that number is base of an exponent, then you have the result as that exponent. Last, again, base match situation, but this time logarithm is on top of exponential base, then they still cancel and get x. So I call this kind of cancellation laws. You get p, and this cancels, you got nothing, it's just 1, and this wipes off the 0. All kind of simplification rules, but these are something else. These are new now, 5, 6, 7. This is called product property. I believe there is somewhere a product. Where do you see the product going on? Where is the product? Yeah, it's right here. And you see things multiplied in a logarithm, they are multiplied, you see? You can split them apart. Well, is this a typo? It looks like a plus I see here. It's not a typo. Most people, this is a very common misconception. Even I sometimes say, what's the plus or product? Even I do that. But most people feel, oh, this is a product that must split as a product. No, they don't split as a product. They split as sum. If you want to call this, actually, call it sum property. It's actually product sum together used in this property. Product sum property. Products turn into sum or addition. Okay, addition property. Okay. They call this quotient because there's a quotient or division. Isn't product and division opposite of each other, right? Divide, multiply, divide. So I believe the opposite case is going to happen here. Look, addition, what is the opposite of addition? Subtraction. Quotient or division subtraction property. Divisions turn into subtraction. Okay? In case we need to split logarithms into two pieces, it depends on the need. If they ask us, you do that. Otherwise, we are okay with divisions. What's wrong with them? Nothing. And the last one I call it power. Look at P as in power. There is a power here, right? And whenever you have a power, look what happened to it. It escaped from this prism. It goes in front. So logarithms are vulnerable to powers. When the power shows up in the logarithm, they just run away from logarithm. They come in front. Just keep that in mind. Just like it's happening here. This power is kind of killing the logarithm, but it's killing the logarithm because there is a match. So this is a strict requirement. You need to have a match. Here you don't have a match, you see? These two are different. When these two are different, the only thing you can do with this power is you don't kill the logarithm and x, you just let that p escape in front. You see, no more power. So logarithm is a good power killer as well if you think the other way. Because in calculus, for example, when you go to calculus course, sometimes some equations have a lot of powers. Actually, in this section we will do that as well. If you want to bring power into ground as a coefficient, we always take logarithm of both sides. Okay? So logarithms and powers don't get along. They kind of bring the other down. Okay? Here's the question. It says, it even tells you what to use. So this is a no-brainer. It says use the product property. So you should certainly look at this. And basically says break up this into two logarithms, sum of two logarithms, addition of two logarithms, and even if possible simplify it, not just leave it separate two logarithms. Maybe you can simplify one, do the simplification by using the rules on the left. So in simplification part, if it's possible, we will use one of these fours or maybe a couple of these fours. But we will first basically split this into right in the middle. There is a product. You will split this into logarithm of 16 and logarithm of c with a sign in the middle. What sign? Plus. Don't put a product. I know it's very tempting. It's a product, but no, it's a sum. Alright, that's our final answer, right? Now always think twice before submitting an answer. Can I, especially the number, logarithms consisting of only numbers. This has only numbers. This has c. I know I can't simplify this. I don't know c. I can't figure it out. I know I can simplify this one maybe. Now I need your help. How can I simplify it? By using one of this. Is it 1, do you see here? No. Is it a matching pair? No. Is anything powered, raised to powered? No, I'm clueless. I don't have a clue. Any help? All right, one idea is, it doesn't seem like there's a power here, but maybe you can break 16 into factors and raise them into a power. Interesting. Can you make 16 into power of a base? Like, is it 3 squared, 4 squared? Oh, 4 squared it is, right? Yeah, I can make 4 squared here, but is it convenient? Is it gonna work? Think of 4 squared here. Can you cancel 2, 4, and square? No, try harder. You can do better than this. It's not just 4 squared, 16 is. It's actually, you can break 4 into another couple of 2s. And it is, isn't it 16 quadruple 2s? 2 times 2 times 2 times 2 is 16. So it makes 2 to the 4th. Why is this better than 4 squared? Why? Again, let's compare these cases. Why I wasn't happy with 4 squared, but I'm quite happy with 2 to the 4th again? Why? Yeah, there is a match in these bases. They cancel. Earlier, you couldn't cancel 4 and 2, but you could at least bring this power in front by the power rule, but this is even better. Again, log base 2 of 2 to the 4th is nothing but, look at this, only 4. Okay? You're thinking, oh, I can just put this in a calculator and get to the same result, but don't, okay? Don't. Try to do this by hand as much as you can. Make sense? Alright, going for the next question. What's the situation on this one? Where is the product? I'm wondering where that dot is. What's that? After V? I'm okay with that. You can put the product here and separate this as 97V and then W, 2 pieces. Or can I put the product here and separate this logarithm as 97 first and then VW separate? Can I do that as well? Either way is fine, because you will keep going afterwards because the question is not over. It doesn't have 2 pieces. So I will first put the dot here and separate this into 2 pieces as log 97 and log VW. And what is the sign between? Plus. And then I will go to here. Look at this. There's another dot, another split. That's it. So your total is this. Alright, we're done with separation. How about simplification? Anything, any part, any one of these logarithms you think you can simplify? And our usual suspect is this one, right? This has the most promise, right? To simplify, but can you raise 97 into power of something? Can you? I wish that was 100. Because what is the base of this logarithm? 10. If this was 100, I could make it 10 square and cancel, but 97 is a prime number. It won't break to anything, it won't raise to nothing, right? So I will just leave my answer like this. It's not gonna separate. Or maybe 97 can be, no, it's prime, right? It won't have any factors. If this was 96, maybe I could break into more factors and separate, but no. This is it. Okay. I still want to try that. Okay, so that we're good. And guess which rule are we gonna use? It says what rule to be used, but I kind of took off the help. You need to figure out, when you look at the question, you need to figure out which rule we are gonna use. Which rule? Number 6, quotient rule. Because this looks like, just like that, right? X over Y. So this is a no-brainer. Yeah, some of these questions are just to see if you can do it. You can see and copy things, okay? That's it, right? Yeah, that's a minus. Alright. Let's do the 14. Alright, I'll go quick the next one. But before we go doing that, any questions? Just when you see the quotient, put the top one first, B next. How about now? I see no difference. Are we wasting time here? Alright, I see some differences actually. We are not going to stop with this answer. We are not. Why? Where is the exponent? Good point. There is an exponent. We know logarithms can't resist exponents. When you see an exponent, they just fly away. Agree? Agree? Shall we put this exponent in front? How many of you says, yes, we will let that 2 in front just as promised here? You see P, that P is in front now. I see 2, that 2 must go in front. Do we all agree on this? Raise hand if you agree with me. If you don't agree, raise hand. Only one people? How about, okay, 7. Yeah. So you're not agreeing with me. That's a risky behavior. I wouldn't advise it. But why? Explain me at least why. Why don't you agree with me? What's that? No, this rule doesn't say it has to be matching base. Look, let me make it bigger. This says it can be any x. It doesn't have to be, this is base 10, this can be base m. And this can be 2. It still works. 2, 10, and m. That's not the issue.
Because it's being added to 3.
Yeah, this nasty 3 is spoiling the question. Why? To be able to let a power escape, it must be a power of the entire inside terms. This square must be around everything so you can let it go. This 2 is only power of m, not 3, and these two guys are together in logarithm. Unfortunately, that 2 is locked in there, won't go anywhere. So we cannot do this rule unless the power is the power of whole thing. Okay? So there is a catch. It's not that easy. That power must be the entire stuff power. Alright? Back to paper place. So forget about moving that 2, it's locked in. So you can't simplify this, this is over, that part is over. Why don't you take a look at the first part? What's that? Yeah, 100 is 10 squared, base is 10. Oh, we have a matching base situation here, and power as well. 10, 10, and a power, and some stuff else. These two cancel away, and 2 falls to ground by gravitational force, and one note. Oh, we have a 3 and 2. Can't we add them? Don't they make 5? Right?
No.
What's that?
The 3 is attached to the
Right. Logarithms like prison, and m squared and plus 3 are both inside part, but it wasn't our fault. Actually, when I write like this is a mistake. When somebody reading this, they may confuse, is this 3 inside with m squared inside log or out? Because it seems like 3 is kind of out of this thing, right? So it was my bad, I should have used this thing. When I put both in parentheses, now I know, oh, these 2 guys are in the same cell captured by logarithm. So please use parentheses abundantly. Don't skip using parentheses, because somebody may think this 3 is outside and try to add with 2. No, they don't add because m squared plus 3 are both inside logarithm. Okay? So they don't add. This is our final answer. Okay. All right. Proceeding to the next question. Any questions? I think you're in pretty good shape to try this question on your own for a minute. Please don't confuse the numbers. This 7 is index 7 of this radical. This is connected to the radical. This 6 is the base of logarithm. This cube is the power of n. Any answers? Again, what is the statement? I cut off the statements, but actually it gives you more help in the statement. Apply the power property and reduce this as much as possible. But it gives you the big hint how power property. I have no relation in this question of power property. Where is the power property? This one. This one is power. Huh. I don't have a power there. It's a big fat radical. So I believe we need to revisit chapter 9 in Math 1075, which is about radicals. Because radicals and powers are related. How? You can turn any radical with any power and any index outside into an exponent, a power around a. Who remembers that? Especially if you were my students, you need to be speaking up. This is the right moment. This is embarrassing. Yes, Chantal.
Isn't it n to the third or to the 3?
No, just give me the rule for this one.
Oh, so it'd be a to n over n.
Yes. You take this number, divide by the index, that's it. N over n. This is gonna work great there. Because this thing now, this turns to what? N to the n to the what? 3 and then 7. The order matters, okay? Don't put 7 first. First, the power, and then bottom is index, 7. 3 sevens. So we have a nice and clear power situation here. Just like here, look, this is the base. This is B, base B. This is X, or whatever you call here, X. This is power P. Yeah, it's a fraction, who cares? It's a power, fractional power. Log B XP situation, power situation, and what happens to powers in prison? If you're on the high ground on prison, you just jump off the wall and escape, right? Yeah. P will escape from this prison. That P is 3/7, and we're all set. 3/7 now free of this log. What's inside is these guys. They are stuck. Okay? It's just to warm you up. These are simple, but warm you up because we are gonna start combining all these bunch of tricks together into one question. But I think this is gonna happen here soon. Why don't we finish this one up? It's a 2-second question as well. This is the power rule again. Power. Do you see the power? You can't miss it. A, B, both is a power. But what is ln? I'm confused. I expect to see log. All these rules are for logs with some bases. I don't have a base. I don't have log. What does ln mean? Yes, there is actually a logarithm here. This is logarithm base E, 3 to the AB. Now, how can I apply power rule here? It says power rule. Because power rule is you have a base, you have another base, must have a single power. This is double power. It doesn't matter. No matter what you see, even you see a turkey here, that turkey, entire turkey should fly away. Okay? So 8B is your turkey, move it in front. Do they cancel the E and 3 want to cancel? Okay? Want to cancel, so this is our, oh by the way, don't use log E, switch it back to ln again. So it's just ln. This thing is ln, right? It's just ln3 with A and B multiplied. Okay, we're ready to apply these for more comprehensive questions coming up tomorrow.